Yeah, go to my page, leave your feedback. Do you see the first line? Leave your feedback here. Click that link and leave a feedback. And join Discord if you haven't joined us. And next week is reading week. Reading week. I really need this reading week. I'm so tired. You have more assignments. You have more than before, like more than now? Oh my god. 3 back-to-back tests? For this week? How many courses are you taking? Oh, that's why. That's why. 6 courses, it's hell. Because I've done that before. I've had 6 courses and 3 jobs at the same time before. It was hell. It was literally the worst year in my whole life. It was really bad. Even worse than now. Now it's pretty bad already. I'm dying too. It's okay. We can die together. I'm actually dying. I've been, for the past 3 days, I taught more than 10 hours per day. Sometimes 11 hours, sometimes 12 hours. And today, I'm teaching from 10 to 8 p.m. So that's a lot of hours again. And then we'll do the secret meeting. So that's probably gonna be more than 12 hours today as well. Well, I had no sleep. That's why. No sleep. It's like they said there is a triangle. The triangle is you have social life or entertaining. That's part of the triangle. And the second one is sleep. The third one is your GPA. You can only have 2 of them. You cannot have 3 of them at the same time. Sleep. Yeah, something like that. You can add you for me, I for me it was like school, work, and sleep. So I had school and work, so I had no sleep. It's really bad. For the past few days, I had very little sleep as well because I had a lot of work to do, and I'm still behind on my work. I actually plan to finish marking problems at C by the end of today, so that you guys can get feedbacks, but that's not gonna happen because I haven't started yet and I'm teaching all day long with no breaks today. So that's not gonna happen. Hopefully you guys don't hate me for that. I will I will finish working by the end of Saturday, but definitely not today. We all need a break. I think the reading week is what we need. No one to see their marks anyway. It's not about marks, it's more about feedbacks because you need feedbacks to avoid more mistakes in your quiz so you can do better in your quiz. The handout is on Quarkus, so you go to my Quarkus page and you can see it. It's right there. I have no idea. I feel bad for you too. I feel bad for you because no. Maybe because I have more work. My to-do on Quarkus, it's never lower than 500 now. Like every time, it's usually like around 1,000. My to-do, like Quarkus, they have to-do, and my to-do is usually more than 1,000. Every day I try to lower it so it gets to like 400. The next day something's due and it gets to like 2,000. I'm like, this never gonna end. During regular school, I have assignments during I have assignments every Saturday and Sunday because of 102 and 223. Oh yeah, they both due on the same day, right? Right, yeah. 223 assignment is due on Saturday as well. And 102 is on Saturday as well. But they gave you a week to work on this, so you're not supposed to do them both on the same on Saturday. You're supposed to finish it by Saturday already. Although you might not have enough time. I understand that. It's okay. Although I said that, but I do that a lot. I personally, if it's due on Saturday at 11:59 p.m., then I start on Saturday up around 9:59. Usually I start 2 hours before the deadline. It's like a lot of pressure on me, and that's when I work most efficiently in my whole life. It's like the less time you have, the more efficient you are. So that works perfectly on me. You see me on Discord on Friday for 2 to 3 assignment. I mean, I see people talk about it, but I don't know who's who, because Discord you don't use your real name. Unlike me, I use my real name. I used to do that, but I'm getting so much work to do, so stressed. I need to keep me going. I'm not stressed out. You use your real name. I'm not stressed out at all, but I'm just tired, to be honest. For me, I'm just really tired. Like, not mentally, physically really tired because I've been talking a lot. There is not enough time, you give up. Oh, if there's not enough time, then you just don't do it. That's how it works for me. If there's not enough time, then I'm just not gonna submit anything. Again, that's terrible. I was a terrible student, so do not copy me. Okay, I was a terrible, terrible, terrible student. And probably a terrible TA as well. Anyway, um, I do not have good study habit at all. I always do things in the last minute, and I skip lectures a lot. I skip tutorials a lot too. Usually during the daytime, I feel like if the tutorials and lectures were at night, like after midnight, I would attend them. But for me, during my undergrad, I usually spend the daytime sleep, and at night I get up and I do my work. So usually I'm like sleeping during the lecture time or tutorial time. And so if they are like at 3 a.m., then I'll probably attend. But they are at like 3 p.m. That's my sleep time. Yeah, that's basically why I skipped a lot of lectures. Also because I was really busy with my job, like my other work. So school was not as important as my work because I need to eat. If I don't work, me and my sister will starve. So not can't let that happen. So I had to spend more time on my work instead of school. I had multiple jobs at the same time. I don't know what to say. You wake up every day around 9. I cannot wake up at 9:30. I really cannot do that. I can wake up at 9:30 p.m. but not a.m. Sometimes I wake up at 11 p.m. Okay, we should do 102, by the way. That's enough chat. We can chat some other time, but now we do 102. Well, we wasted 3 minutes. My office hours is usually full, so we don't have time to chat either. My office hours is like usually people line up for questions and I can't even answer all the questions. Pretty sad because they changed the office hour from 1 hour to half hour per week. Okay, so let's talk about today's material. So originally I was gonna do fields and not sets, fields and then logic, but I had a look at your problem set. It doesn't look so good. So I feel like it might be better to do a quiz review. So first is already passed. We did a bit of review in my first tutorial. So we'll do the same thing for this tutorial. And there is something that we do not speak of, okay? And it's at this time, same link. I do not want to get into trouble, so do not let your professor know. You can let other students know, but don't let your professor know, okay? Because I might get into trouble. I actually got into trouble before because I held extra office hours, had a 1 hour talk with a professor. So yeah, same link. Yeah. So same link at this time today. We'll do a bit more review. So we will do what's left for today. So I don't think I will ever reach fields today. So we'll never reach this. And last time I didn't reach fields either. So tonight we will focus on this a lot and we will do other questions as well. So that's my plan for today. Any questions before we start? Can we start at fields first? No, because I don't, because last tutorial we didn't start as fields, and I don't want to do different things for different tutorial because the first one was not recorded. So we will do fields tonight, mainly just fields tonight, I think, because I think you guys know how to do sets and image after today. So tonight will be mainly just fields. Go back. Will it be just same tutorial? I'm trying to make it more active, like interactive, not active, interactive, because I think it's really important for you to try the questions first. So tonight I will mainly give you some time to work on it, and we'll talk about how to approach the question instead of just me talking, because I've been talking for a long time. I'm really glad my voice is not cracking yet. It might be, but I'm losing my voice. I can feel it. It's getting harder for me to talk now, but we'll see how it goes. Anyway, yeah, so tonight's review is more gonna be like discussion. So I'll let you guys discuss with each other. That's gonna be helpful because I've tried it before and it works very well. When people discuss with each other, it actually works better than me just do lecturing will be better. So I will try that. And if it doesn't work, then I'll just teach you. But anyway, let's do set. So I wanna emphasize something is everything here is what you can use directly. Okay, everything here. So everything in this box, you can use them directly without any of the proof. You can use them directly because they are the definitions. And everything in the box is what you can use, nothing else. Well, there is something you can use, which is De Morgan's law for logic. So you can use a definition. I'm not gonna repeat this because I did it last week, okay? So we're not gonna waste time on repeating those. But what's in your toolbox? The first one is a definition of set operations, which is what's in the box. Okay, everything here, you can use them directly. The second thing is De Morgan's law for sets, which is a claim something, 2 point something in your textbook. So that set identity, it's called De Morgan's law. You can use it directly unless the question says no set identity. Because they've done that before. They said in the question, they said no set identity. That means you cannot use De Morgan's law anymore. Okay, when you use De Morgan's law, you need to reference it, yes. When you use this, you need to reference it. When you use the definition, it's okay, you don't have to. It's better that you do, but you don't have to. But when you use De Morgan's law, you have to reference it. Does that make sense? Okay. And not for definition, yeah. It's better you reference your definition like by definition of set differences, but you don't have to. Like what I meant you don't have to is you will not lose mark if you didn't do it. Yeah, you can do that. You can definitely do that by definition of set intersection. This means that blah blah blah. That would be good. That's perfect. Chapter it's in chapter 2. So you did learn the De Morgan's law for logic. That's in chapter 3, which you cannot use. You lost mark? Really? Who's your TA? You can definitely do that. I think I told them you can do that. I definitely told them you can do that. I'm not sure why they didn't give you the mark. But anyway, you will not lose mark on the quiz. That's definitely, I will specifically tell them you can use those. I actually specifically told them you can use those for the problem set as well. Not sure why they didn't listen, but okay. For the quiz, you can definitely use all of those directly without any other explanation, okay? Because they're just definitions. However, if they're not here, if they are not De Morgan's law for sets, then you cannot use them. For example, you want to use certain set identities without a formal proof. See, you did the same and you didn't lose mark, and some of you did the same and lost mark. I don't know how that happened, but okay. No comment. But my point is, anything else you want to use, you have to prove them first. Okay, anything else, for example, you know another set identity, you want to use it, then you have to prove it first, which I do not suggest you to do that because that's gonna waste a lot of time to prove another set identity. So do not do that. Only use the definition. Okay, only use the definition. Anyway, next. So this is how do we prove two sets are equal? I'm not gonna talk about it anymore because I've talked about it many times. So hopefully you know what's going on. If you do not know, you can read it yourself. I wrote it here already. So let's try last year's quiz question. We have ABC, they are sets, and I want you to prove using double inclusion. Such using double inclusion, this is equal. So I want you to try one direction. Doesn't matter which direction you try, but I want you to try one direction. So I'll give you some time to work on this. How much time do you need? Let's say 5 minutes. Okay, I'll give you 5 minutes. I'll give you 5 minutes to work on one direction. Let's do the forward direction. So I'll give you 5 minutes to work on this direction and we'll take it up. Okay? This is really, really, really important. Make sure you know how to write how to prove two sets are equal, because this will be tested on the quiz, on the test, and on the final exam. So if you don't know, you will lose a lot of mark in this course. Nah, I didn't have time to do that. So we'll do that tonight as well. So last week's material and this week's leftover, we'll do both tonight. And we'll probably do more questions as well. Mainly focus on fields because I haven't touched fields yet. Let's say 2:30, we'll take it up. Or when I finish writing, I'll take it up. Either way. Okay, I finished writing, so I'm gonna talk about it. This time I used a really formal proof because people are saying my proofs are too simple. Let me see in the chat. The question seems fine, but I feel tomorrow version is gonna be harder. This is what people always say. They always think their test is harder. To be honest, this is my favorite type of question to do. Actually know how to do, but there's catch. Doing the quiz, that will be a different story. Okay, we'll see different types. So this is what I wanna say. Usually, if you know me well, you would know that my proofs has bare minimum English in there. It's basically all math symbols. However, people are saying my proofs are too simple and they are not well written proofs. That is correct. So so I feel like I should write a really formal proof here. So that's why I decided to do that. It's basically the same thing, except you should add a few justification in between. Okay, but it is the same thing. And I'll answer your questions. You don't have to do this for a quiz, but it is really important for you to know how to write a good proof. So you should practice on your problem set, for example. Okay, try to write a formal proof on your problem set, but for your quiz, since you don't have enough time, what we did before is totally acceptable. So you don't need to have like those. You can just like let this, we know this, and then we know this, and we know this, we know it's in A, so it blah 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 blah. Okay, so you don't need to, you can make your proof much simpler or much less formal during your quiz. That's totally fine. And yeah, so I do want to write a full proof at least once in my tutorial so you guys know what you should do, what you're supposed to do. But for the quiz, since you don't have enough time, it really doesn't matter, okay? As long as you justify the necessary steps, it's okay. You don't have to say, oh, by definition of this, by definition of that, blah, 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 okay? You don't have to waste your time on those, but you should justify your steps. Yes, it's fine. So my previous tutorials proves they are all fine. They all deserve full marks. It's just they were poorly written. This is not an element. Did I wrote it is an element? Where is it? Is an X is not element of A or C. X is not an element of A minus C. And X is not in A or C. Where are you referring to? Okay, seems like I have no problem. Okay, so I will explain. So since we know X is in this, we know that X is in a set minus another set. That means X is in the first set and not in the second set. That's how we get this by definition of set difference. And then this part will tell us X is in A and X is in B. And the second part will tell us X is not in A or X is in C. However, we know that X has to be in A. That means for this condition, you can only pick the later one, okay? Because we know X is in A already. So it must be X is in C for the second condition, which means we have X is in A, X is in B, and X is in C. Okay, that is basically the definition of this. So you prove the first direction is a subset of the second direction. Okay, any question? My writing is getting worse and worse every day. Uglier and uglier every day. Kind of sad. If my mom sees this, she's gonna yell at me. Anyway, anyway, if no question, I'm not gonna do the second part because the second part is basically the reverse of the second part of the first part. So I'll give you a full solution. However, we're not gonna do it here. Okay? Do we have any problem? Is it okay to use words and say if after using what? You could use even only if. Yeah, you could. You could. It's just it's the fact I really like to use if and only if, but a lot of TAs are complaining because I taught you if and only if, and they said proofs are not always if and only if. I know too, and I told you guys too, but people are complaining, so I'll change. I'll make some changes. Anyway, it's good feedbacks. I like it. Oh, by the way, you guys go to my Quarkus page. The first line says give me feedback, so you should give me feedbacks. I have less than 10 feedbacks, and there's like you have 61 students, 60 students here. My last tutor has 60 students too, so there's 120 of you, and I only got 10% of you giving me feedbacks. You can use if and only if. As long, okay, you need to be careful because sometimes it's not reversible. For example, if they ask you to prove this and you do not know if they are equal, and if you use if and only if everywhere, then your proof is wrong because the reverse direction is not correct. So when you use if and only, you need to make sure each of your steps is actually reversible. Okay, that's why people complain because not all proofs are reversible. Most of them they are not. They can only go with one direction. Okay. Yeah, basically, if it's equal, most likely it's reversible. Most likely there are some exceptions, so you need to be careful. Okay, so we will move on because it's 36 already. We'll move on. The second part, I will give you a full solution. But for now, we'll move on, okay? Image. So image, I found that most people find it really, really hard. Hopefully last tutorial gave you some idea of what image even is. Hopefully you know the definition by now. And this whole huge box is telling me how to prove the image of a function equals to something. I'm not gonna go over this because we went over this last week already, so don't want to repeat myself. We'll move on directly and try example 2. So this time, my point is I want to show you something that has two variables in there. So I want to, okay, I forgot to check the chat again. Ha ha ha. Okay. You're not in the image. So yeah, you don't have a girlfriend? No, I'm just kidding. You're not gonna get haunted. Anyway, back to this. So this tutorial, I want to show you some functions with two variables because you've never seen them before. However, they can test you on them, okay? Because well, both of the questions are quiz questions. So we will see some questions that involves two variables instead of just one. And hopefully, if you get tested on them, you know how to deal with them. For one variable questions, I think we talked a lot about them. I will probably do one more question tonight, and yeah. Okay. Yeah. So let's look at example 2. So it's a quiz question from last year. So we have F maps from Z Cartesian product Z. So integer Cartesian product integer two integer Cartesian product integer. Okay, those are Cartesian product. They are not actually multiplied together, because people always think we're multiplying them together. You are not. Okay, you are not. It's Cartesian product. So it's something like AB such that such that A is in Z and B is in Z. So that's what it means. You are not multiplying them together. And we have this function which is given by f of xy equals to x plus y, x minus y. So this is my function. Now you need to find an element of Z, Cartesian product Z, which is not in the image. So what are you looking for? Not in the image, so what are you looking for? Well, your codomain is integer Cartesian product integer, so it's always integer. No, you are looking for integer pairs, okay, integer pairs, but if you solve this, your x, y will not be integer. Does that make sense? So you're looking for the single boys who doesn't have a girlfriend. So single boys, no girlfriend, which means your x, y are not in this. Does that make sense? So you have something from here, but there's no integer dot integer that maps to it. That's basically it. So this question, I think there are many ways to do it. Okay. I like my way, but some people said it's too intuitive, so I'll use something else that's not so intuitive. So basically what you can do is you can let this equals to, let's say, A and B. Okay, that means your x plus y equals to A and your x minus y equals to B. Then you can express your A and B using, you can express your x and y using your A and B. So this will give you x equals to A plus B over 2 and y equals to A minus B over 2. Okay, so if you look at this, you'll see that your x and y, okay, A plus B and A minus B, they might not be even, right? Sometimes they might not be even. So this means, well, you definitely have something that can never be mapped to. So for example, if you look at this, you'll see that one has to be even, the other one has to be odd. So this tells you x and y does not have the same parity. So as long as you pick your x and y, one even, one odd, then you're good. How do we get it? So we wanna isolate x and y. Oops. So we want to isolate x and y. If you add them together, you get x plus y plus x minus y equals to a plus b. So 2x equals to a plus b, x equals to a plus b over 2. And similarly for y, okay? Any other question? So your counterexample would be anything that doesn't have the same parity. For example, you can consider what? 0, 1, 1, 0. 1, 0 is in Z. Cartesian product Z, right? So that means f of xy equals to x plus y, x minus y. Oops, I added another bracket here. This should be equal to 1, 0. So you need to solve this equation, which is x plus y equal to 1, x minus y equals to 0. And then what would this give to? Your x's, so you add them together as your x, so that's 1 over 2. And your y is also 1 over 2. This is not an integer. This is also not an integer. So basically you got, so you know that they have no, they have no, so since 1 over 2, 1 over 2 is not in that Cartesian product Z, we know it's not in the image. So they don't have their corresponding girlfriend. Okay? Any question? No? Does it make sense? Okay, so it seems like I need to do it again. This is how we found this is how we found x. Why you do the same thing? You have two equations, 1, 2. What can you do? Add them, multiply them, minus them. So 1 minus 2, you would get x minus x, so it disappeared. Okay, minus x minus y equals to a minus b. So y plus y, so 2y equals to a minus b. Y equals to a minus b over 2. It's exactly like this. So when your a and b are numbers, you know how to solve it. When they are variables, you don't know how to solve them. You don't need this. You don't need any of this. This is all you need for this question. Okay. How do we get 1, 0? I just said, because your x and y does not have the same parity. When your xy does not have same parity, you can get something that's not in the image. So I just picked something. Pick one even number, one odd number, then it works. Yeah, yeah. Q to Q, map to Q to Q. Then I doubt you would have anything that's not in the image. Because, well, this counterexample doesn't work anymore. Yeah, and this doesn't work anymore either. 1 over 2. You add them together, that's 2x equals to 1. So x equals to 1 over 2. But guys, this is high school stuff. Yeah, 2, 3 works fine. Well, we have some examples where domain and codomain are different. Well, they can be different. For example, here, they are different. Domain, codomain different, and 2 variables, and absolute value. What do we do? Everything you don't like are here. Everything you don't like. You guys don't like Cartesian product. You guys do not like 2 variables. You guys do not like absolute value. And you don't like image questions. Now what do you do? Yeah, that's why I want to show you something like this. So if you see something like this on your quiz, you don't freak out. At least you have some method to deal with it. At least you can try something, right? So that's why I want to show you those questions so that if you see them, you can try something. X is precondition is X is an integer. What do you mean? What precondition? Are you talking about this question? No, X is not integer. X is here. X is integer. Yeah, X is integer because it's Cartesian product. So this is from here. This is from here, which means X is an integer. Y is also an integer. Here, my X and Y, they are both natural numbers. So how do I prove this? Okay, don't freak out. Think, guys, think. Yeah, we all know it's subset inclusion. So I'll write the first part out and you need to think about how do we prove this, okay? It's not hard. It's actually not hard. So you need to think, use your brain. So I wrote the first sentence, let Y be in this. Then by definition of image, there exists AB in natural Cartesian product natural numbers such that G of AB equals to Y. So now what we need to do is we need to show that this is in this. So we have absolute value of X minus Y. You need to show that this is a natural number union 0. So what do you need to do? Okay, let's look at the chat. Difference of natural numbers is an integer, then absolute value of that must be a natural number of 0. Using definition of absolute values, this is greater than or equal to 0. Yes, you guys are all correct. Okay, you are right. You're right. So we know this is definitely greater than or equal to 0. So that means it's non-negative, and also it's gonna be natural number. What, how do I say this? Let me think. Also what? Also X minus Y must be integer. So when you use this, it must be this. Okay, that's great. Great, so we have this. So this shows that my Y is in 0 union integer. No, I mean natural number, sorry. Keep saying integer. So that's my first half. My second half. Now I let Y be an element of 0 union into natural number. I say integer again, can't believe that. Okay, so now we need to find AB in natural Cartesian product natural such that g of AB equals to y. So now what you need to do is you need to find your A and B. So find your A and B. Okay, let me look at the chat. Is there a reason you wrote A, B instead of X, Y? Oh, yeah, because I used Y as an element of the whole thing. So I cannot use Y anymore because this Y has to be from the domain, but this Y is for an image. So you don't want to use the same variable for two different things. That's why. Okay, nice. So we got it. Y plus, oh my God, Y plus 1, Y. That is my AB. So consider Y plus 1, Y, or 1 plus 1, 1. This is in 0 union integer. Can you guys see this? I feel like it's not so obvious. Kind of worried. Okay, this is better. This is in this, and also g of y plus 1, 1 equals to the absolute value of y plus 1 minus 1, which equals to y. Okay, because y is positive, you can remove the absolute value. So we're done. We can say y is also in the image. Oh, it's not f, it's g. So y is in the image of g, and you're done. It's y plus 1, 1, not y. Yeah. How do we get it? So this is what I want to say. That's a great question. So this is what I want to say. When you have two variables, so when you have two variables like this, sometimes it's much easier if you can fix one of the variable. So for example, I fix my y to be 1. As long as this satisfy this condition, then you can try something like that. Okay, sometimes fixing your one of the variable is really helpful for you to figure out what your proof is, especially when we reach surjective, injective surjective functions. A lot of time you need to fix your one of the variables to 1 or 0, something like that, and then you can figure out the rest. Without that, it's really hard. Any other question? You don't have to use this. You can also use something like y plus 2 and 2. You know, once you fix this one, the other one is really easy to figure it out. So we just set the absolute value of, no, I meant you fix one variable that can help you with finding your x. Does that make sense? It's not like you are changing the function. It's by fixing one of the variable that can help you with finding one of the with finding the x, or finding the inverse, if you want to say. Otherwise, you do not know how to deal with this. You should conclude, but I'm running out of space. Do I have another tutorial? Hold on, let me check, because I'm not sure. Oh, I don't. Nice, I have a break. Okay. Do I need to conclude? You should conclude, by the way, you should conclude. So basically what I did is I'm gonna fix this So let's say this is 1. So I wanna find my I should not use x and y. So let's change it to a and b. A, b, because I used y here. I don't want to use the same thing. A minus b. So I fix b equals to 1. Then I have g of a, b, a1 equals to a minus 1. And I want this, oh my god, I want this to equal to a. No, yeah. Not necessarily a, actually. I don't want it to be a, sorry. What do I want it to be again? I want it to be y. Where y? Yeah, I want it to be y. I want it to be equal to y. So now you need to find what is your a. Okay, where y is not union, 0 union natural number. So it's always non-negative. So you can open the, you cannot, never mind. So you cannot, but it doesn't matter in this case because you always have the absolute value. So that's gonna make everything positive. So even if you remove this, I mean, this is rough work, okay? Rough work. Even if you remove this, it's the same thing. So you'll get a equals to y plus 1. And then you plug it back in. That's gonna give you everything. That's how I got this, by the way. How can x minus y in integer? Because natural number minus natural number can give you an integer. YB is fixed equal to 1. It doesn't have to be 1. I just picked a random number. So the whole point is you fixed one of the variable and you find the other one. It does not need to be. I don't have 2 y's in my proof. There is only 1 y, right? Oh, I see. I do have a y here. Sorry, my bad. That is my bad. I should use another variable. I see. You can talk. Yeah, sure. No problem. Let's use and then. My bad. I did use 2 y's. That's really confusing. I see what you mean. So let's use this such that GAB equals to n. Because we want to avoid y if possible. X minus y is greater than this, blah, blah, blah. That's okay. And then let's change this to n. And so this is n as well. We need this to be n. So I want it to be n plus 1 and 1. You are right. Okay, those should all be n. Because we don't want to use y. And why did I use x minus y? It should be a minus b. Sorry. My proof is really bad now. Okay, let me see. I used a b here, and I used x y here. Should be a b. Sorry. Don't know what's wrong with me. A b, a minus b. So a minus 1. Wait, what? Wait, a minus y, a minus b. Okay, now it looks much more cleaner. So actually you can use xy now because I changed this to n, so you can use xy now if you want to. can I? Oh, yeah. Go ahead, talk. You can talk.
So I had a question regarding like the first half.
Mm,
So when you say absolute value a minus b is greater than equal to zero, so that's based on the like the triangle inequality rule. So then why do you just take out the like so I'm guessing you take out the absolute value to say that if you subtract like two natural numbers, you could get um what's it called? A
mm,
number from the integer set.
mm.
But then I don't understand the part next to it. So a
Oh,
minus
so
b, yeah.
basically is this. This is greater than or equal to 0, but it could be real numbers as well. Does that make sense? So we only know this is greater than or equal to 0 for all x in real number. So this part is telling you it's greater than or equal to 0. So it's non-negative. This part is telling you it can be integer, but if you add absolute value, so you remove the negative part of the integer, so it can be natural number or 0. Does that make sense?
But can't a and b only be part of the natural numbers? Like I understand if you take out the absolute value, it can be a part of the set of integers.
Yeah,
But
what do you mean? What do you mean A and B? A and B are natural numbers. Yes, that's correct.
oh, okay, because like you said they're real numbers, so
No. I meant this thing can only this. So this is telling you this whole thing is non-negative. Okay, and with this, so this together with this, you know that this whole thing is not is natural number union 0. Does that make sense?
yes, yeah,
So
that's clear as
here
well.
I'm telling you it's non-negative. Here I'm telling you it could be integer. So allow those two adding together would tell you this is 0 union natural number. That's how it works. Because here you are not telling me why the y is a natural number, right? You didn't say that. Okay.
Okay, yeah. And then my second part, so like I so what I'm not getting, I know you explained it already, but it's still
Mhm.
not clicking with me. Like you're fixating like you're saying so wait, so like you're saying n plus one here, right? So is the
Mhm.
one like corresponding to like the variable b or like
Yes. Here I fixed b to be 1. So this 1 is your y or b. I probably should have used x and y, but okay.
what about like in terms of like the question, like in terms of n,
N? What do you mean in terms of N?
like in the second part, like you're proving the other side, yeah. So
Oh,
n plus
the
one.
thing is, okay, here is the thing. The thing is your N is an element of this. So that's changing. However, this whole thing, as long as it's in this, then you are good. So we know 1 is in this, so you can definitely use it because we know this is in this.
Oh,
Oh, no,
okay.
not this. I mean, we know 1 is a natural number, so you
Yeah.
can use it. So basically, when I say fix one of the variable, you need to fix it so that it's in your domain. So you
Okay,
know
I
it's
see.
definitely in your domain because the whole point is you need to find something that's in your domain, right?
So in order to prove like a question similar to this, like
Mhm,
where you prove the image is a subset of the function, you
mhm.
would have to kind of fix a value for it in order for it to
You don't
follow the
have
domain.
to. Okay, you don't have to. It's just a trick for you to find your
Okay.
domain easier. Because when you have two variables, there's how can you find such thing if you have two variables? So if both things are changing, then it's really hard to find something like that. So this is just a trick for you to find your the find your AB easier. That's the whole point of this. So it's just a trick for you to find it easier. There are many of those that works. For example, you change it to 2, it still works, right? There are many things that works, but this is just one way for you to find one easily. Does that make
Uh,
sense?
yeah, I think I get it now. Like
Yeah, so
it
you
looks
don't
easier
have
now.
to do this, but if you do this, it might be easier for you to find it. But this is just rough work. Okay, this is your proof. So basically, you just need to find it with however you can.
All right. Okay. Thank you.
Yeah, exactly. It's because you how do you take the inverse of a two variable function? We don't know how. That's why you want to fix one. And when you have only one of the variable, you know how to find the inverse. It's basically because of that. Does that make sense? This is only possible due to domain of being natural. Are you talking about the trick or are you talking about the question itself? The trick works with something else too. There are many things that you can use this trick. It's about two variables. It's not about integer. No. This is an element. Oh, my bad. My bad. My bad. Here should be here should be this. You are right. You're right. Oh, you're not right either. Should be element of and Cartesian for that n. What do you mean it wouldn't work if it was R? If it was a real number, Cartesian product real number. Are you still talking about that? If you only have one variable, then there is no trick for you to do. It's more about two variables. And also, if this is real number, Cartesian product zero number, then you can get anything. Then the image is everything. There's nothing for you to prove anymore because you can just fix. Do you know how to show it can give you anything? So for example, let's change it to real number to Cartesian product real number to real number defined by g of xy equals to this. Similarly, you fix y, I'm gonna fix y equal to 0. Then g of xy equals to, oh, it's not all the real numbers, sorry, it should be positive, non-negative real numbers. So that's gonna give you x minus 0, I mean x0, which is the absolute value of x. So the image of this will be all of the non-negative numbers. It's not a proof, it's just showing you can fix one of the variable as well. It's not a proof, okay? Does that make sense? Yeah, so if you're given two variables, so Cartesian product, so two variable give you one variable, then this is a really good trick for you to try something like that. Like it's something like this, something looks like this. For example, for this question, it wouldn't work. Okay, any other question? So something like this, you see, it still works. If you fix y to be 0, then you can get all the non-negative real numbers. Doesn't have to be absolute. Yeah. It doesn't have to. It's more about variables. It's not about the function itself. The mapping, I do not understand. What do you mean Cartesian to R, the mapping to R doesn't really matter? Are you saying the codomain doesn't matter? Oh, I see. For now, you don't care about the codomain that much, but when we reach uh injective surjective functions, we do care about codomain because I can give you a spoiler spoiler alert. So surjective function is basically when your image equals to your codomain. So we'll reach there, we do care about the codomain. Okay, okay. Any other question? Don't leave if you have any question. You can leave if you don't have any question. What do I need to change? Change this? Oh, yeah. You're right. Because I changed it to N, didn't I? Yep. Any other thing? Someone asked about this. So this, you know that it's a plus b over 2 and a minus 2 over 2. So in order for them to be integer, right, they have to be even. Does that make sense? So if you make one even, one odd, then it's not gonna be integer anymore. Does that make sense for whoever asked this? Mandy, does that make sense? Okay, cool. So we know this have to be even in order for them to be integer. So if you make one even, one odd, then they're not gonna be integer anymore. Okay, any other question? You can leave now if you don't have any question. Okay, last call. If no one has any question, I'm gonna leave. 3. Where do I post the second part? The second part? What second part? This question? Are you talking about this one? I'll post it on Quarkus. Okay, just unmute yourself.
I just had a quick question. For like when you did the tutorial for 2.2 and 2.3, you put out the worksheet, but you said you were gonna put out the answers later. I was just wondering
Are you talking about last tutorial?
uh not the last one, the one before that.
The one
I think
before?
that's the yeah.
2?
It's tutorial 3. Tutorial
3
like
is
called
the
tutorial
last
2.
tutorial.
2, sorry.
2?
Yeah, 2.
I thought I did post the solution.
Because I can only
I
see
did
like
post the solution.
because I'm looking at it and I can't really
Let
see
me
like
check. I thought I did. Well, the video is posted, that I'm sure. Let me see. If I name the voice solution, it should be there. Yeah, wait, that's 1, 2. Oh, so I did not. Okay, I'll post it now then.
all right.
Thought I did, but I didn't. Okay.
No problem.
For the third one, we will do them tonight. Yeah. So for the rest, we'll do them tonight. So I know I didn't do those. We'll do them tonight. And for the fourth one, we'll do the rest tonight as well. It is post on Quarkus. Yeah, so tonight we'll mainly just do fields. Okay, I'm gonna have a break.
I just got a quick question. It's like for all your like for all these examples, right? For the quiz, should we just practice the ones that say like example quiz?
What do you mean? Are you saying only focus on them?
No, like for like extra practice, right? For example, like example 3, 2019 winter quiz. Like for the last 2 tutorials, you had like quiz questions, right? So should we just practice them again?
Sure. I mean, I said I'll do them tonight, but sure, if you wanna practice, you should.
Like if you recommend it, like
I I don't want to make any recommendation because I think all the questions are pretty good. So I
Mhm.
can't tell you to practice with all the questions. Just pick the ones you like, basically, because all of them are pretty good. If
Oh.
they're not good, then I won't even post. I won't even put them on my tutorial worksheet, right? So they're all pretty good.
Okay. Okay. Thank you so much.
No problem.
Have a good day.
You too. Okay, I really have to go. I've been talking for many hours now. So bye guys. It's the whole, it's the 2.1, 2.2, and 2.3, okay? If any more question, let's just talk about them tonight. Because if I stay here, this will keep going. So we will end here. And if you'll come tonight, then come tonight. If you can come to my office hours tomorrow.